Hi everyone. So I wanted to do a quick video and an update on my home lab. So those that have followed any sort of coverage of this was what everything looked like. We had a bare metal Optiplex cluster, 5 nodes, physical bare metal, whatever you want to call it. That then had 2 really old storage systems, and there were some plans in there to run some workloads. Cilium as the CNI, Rook-Ceph as the storage, some Kasten stuff to protect some workloads, Kubevirt, all of that good stuff. And then I had a little bare metal vSphere cluster running on 2 nodes using that shared storage. And we were running some virtual machines in there and some nested virtual machine Kubernetes clusters. Well, things have progressed, expanded, considering 3 years ago, I got rid of said HomeLab, an actual rack, half rack height that was in my garage. And I decided that all my HomeLab now was going to be in the cloud. It was going to use a bit of AWS, a bit of Microsoft Azure, and that would do. And then just recently, we found these Optiplex 7060s, really good price, really good. So you're looking at around £100 if you're in the UK, probably just over $120. And they can go up to 32 gig, and you can add an NVMe and an SSD. So that's what I've done with both of those, or all of those 5. I still have those goals of getting some nested stuff, but for now, let's just move them completely out of the way. But yeah, back to the hardware. Really, they're the i5 8500s. They've each got 32 gig. They've got some sort of NVMe and an SSD where the operating system is. And I basically did a administration error with the certificate for my Talos Kubernetes cluster and lost access. And instead of troubleshooting and getting things back up and running, which I did run through that, I decided that actually I was going to just build new, and I was going to use Omni. And Omni is just a managed interface, cloud interface for my Kubernetes clusters. So the plan is still very much, we have Sidero Omni, and that gives us the ability to deploy to these bare metal clusters. It can deploy to any node. Like that could be, and in fact we'll get onto that. I want to be able to run a VMware based Talos cluster as well, and a RaspberryPi, and who knows where else we can run that. But the premise of the underpinning technology will still be Cilium as the CNI and Rook-Ceph as the storage, taking advantage of those NVMEs that we have in there. So these Netgear NAS boxes, I've got a Netgear Ready NAS 716 and a Netgear Ready NAS 312. And they were kind of blurring, the lines were blurring as to what they were doing. They were very much presenting presenting data stores into that vSphere cluster, both of them running spinning disks. So what I've done is I've actually expanded the 716. We now have 6 times 1 terabyte SSDs. So giving us RAID 5, what's that, around 4.5 terabytes of usable VMware data store, or Hyper-V, or Proxmox, whatever we choose to do here. And then what I've also done is I've expanded that vSphere cluster with those 7060s, and I'll touch on where those are pre-existing 2 vSphere hosts have also gone. So I basically have a cluster of 5 Talos bare metal 7060s and 5 vSphere hosts, and then 2 others that I'll touch on shortly. So all of these live on the same network, and they all connect into this 24 port 1 gig Dell switch that I have. We're just going to do some jigging around here and make this diagram look a little prettier. So let's group those together, move that up to the side so that we make life a little bit easier. In fact, I've expanded what this looks like even since this video. So go back to the storage is we're dedicating the 312 purely to backup. This is still running two 2 terabyte disks in a RAID 1, so a mirror, so it gives us just under 2 terabytes of usable storage, but it's slow. So this is what it looks like to the left of me as I speak to you. You've got your NAS 716 is the big right black box. Then you've got the 312. The white box is my Amplify mesh router. You've got your Talus bare metal cluster there to the left. I actually nearly made a mistake and had them labeled on another bit of documentation the other way round, and the other 5 are the vSphere cluster. You'll see, and this might trigger some, but the Dell logo on the top 2 are different to the bottom 3. That's because they're my worker nodes, and the other 3 are my control plane. Then we have this 24 port switch, which nicely fits in this under this this unit. All the power, UPS, etc. is all underneath, and we try and keep the cable management tidy. Actually, I have something on top of that. I think I'll change the picture shortly and show you. There's basically 2 more units that I put on top of this. These are the existing 2 vSphere hosts that I'll touch on. But yeah, these are all running, these ones on the right are running vSphere 8. They're leveraging that 716 storage. The 312 is going to be just purely for backup storage for my Veeam server. So that's going to be where I send my VM backups, but equally when we get some persistent data inside of that Kubernetes cluster, I'm going to use Veeam Kasten to send my backups to that as well. So yeah, so what that has 6 drive bays. It initially had 4 1 terabyte spinning disks, SATA disks, and 2 100 gig SSDs for cache. And yeah, we've just swapped them all out for their crucial 2.5-inch solid state drives, MX500s, 1 terabyte, and they're all in a RAID 5 type configuration. So that will provide us with our production storage for the vSphere environment, and potentially anything else that we decide to do from a shared storage perspective. Hopefully that'll give us a few thousand IOPS to play with there versus how slow it was before. It would take, just a bit of insight, that would take us 10 minutes, 20 minutes to deploy a proxy for, from a template. So this was just to reiterate what this is. The Veeam backups will live on the smaller one. These are the top 2 boxes that I mentioned. One is a Hyper-V single node environment, and then Proxmox as well. For those not aware, Veeam in 2024 provided the ability to protect Proxmox virtual machines, not LXC containers, but VMs. We've always had the Microsoft Hyper-V, but I thought just having them handy. And each one of these has a 1 terabyte NVMe in as well as for VM storage. Now, not very high available or any of that good stuff. So that breaks, everything breaks. I got these the wrong way round, right? So on the left is actually the Talus cluster managed by Omni, and on the right is the vSphere. So you can imagine how much pain that would have caused if I'd have made bigger mistakes. Anyway, so back to this. So we have a drawing board we have a 7060. This is already built. I'll probably do another video on this later on around Omni and how we deployed that to 5 of our nodes and how we got that set up. And then we've also got our vSphere. If you're interested in virtualization, we can cover some of that as well. Long-standing, I still believe that vSphere is the best hypervisor virtualization technology that we have available to us. There are some cost conundrums that people will have to go through given what's happening with Broadcom or VMware. There's some cost caveats that you're going to have to consider, but for me, features, functionality, especially just from doing what I've been doing over the last week about migrating virtual machines using storage vMotion and the networking stack, like there is nothing that touches that in that world. So these two boxes that I'm putting here, these will simulate the Hyper-V box that I've got and the Proxmox environment that I've got. And then there's one more green box that I'm going to add to this shortly, which will be that Raspberry Pi. And the reason why that Raspberry Pi is going to be part of our environment is because from a Veeam for Kubernetes perspective, we have brought out the ability to protect workloads or be deployed onto ARM-based Kubernetes clusters. So initially that was an Ubuntu box, and I just quickly installed K3s to do some validation. Everything was good, so all good. What I'll probably do though, and I started doing this actually, was let's use Omni, create another cluster, and then have a very simple CSI host path, etc. on that. So what I'm doing here is I'm just going to move so that 716 that I mentioned is going to be dedicated storage just for virtualization. We might use the NFS provisioner within our Kubernetes clusters, but ultimately the main aim of this is to run production workloads, or HomeLab production workloads. I'm using air quotes there. And this will give us some much faster storage to play with, I think. So we're just documenting that. I mean, the video playing and me talking over it, I don't know if it's useful. It's better than just like me just talking, right? So yeah, that's presented over NFS. So an NFS data store into our vSphere environment. All of the hosts have access to that. And then we have the goal. In fact, I already have these. So VBR is already there. We have another Veeam server called Veeam1, which offers us observability of our environment. We have a DevOps management jump host. This is actually where I'm running Docker on that box and a few other things that I don't necessarily today want running in a Kubernetes cluster. However, that may change now that we've bolstered everything up. Is basically it runs 3 containers for me. It runs Rancher for some K3s stuff that I want to do later on. It runs Heimdall, which is a dashboard. Let me know what you use as a dashboard in your HomeLab and whether I'm missing out or whether I should do something else, or at least maybe even cover that in a later video. What I'm doing here is a goal of mine is to spin up that 5-node cluster within vSphere. So basically create 5 virtual machines, add them to Omni, create a cluster, and then we've got a virtualization or virtualized cluster as well that we can almost call dev. And I've got some plans for the cluster where I was stuck on something before around Cert Manager. Actually, we can get past that pretty quick now. Let's just move all of this out of the way. So yeah, the goal is let's create a 5-node cluster. Let's leverage the vSphere CSI. Some of the stuff that we have for Veeam Casting integrates into that. All of that good stuff. It gives us the ability to do some cool stuff there. So then this 312, this Netgear Ready NAS 312, both of these are 10 plus years old. I wrote a blog about these years ago, and basically Netgear gave them to me as a way to basically get some influencer content out there back when blogging was important. So this 312 is gonna only be used as a backup storage target. It's got, like I say, it's got just less than 2 terabytes of storage, and it'll be perfect just for it doesn't have any sort of immutability, but for that really fast 714 30-day type retention, it's gonna do a good job. Yeah, it's just under 2 terabytes. It's basically two 2 terabyte SATA spinning disks, whereas the 716, as I'm about to write out, is 6. It's 6 So yeah, it's about 5 terabytes, and it's 6 times 1 terabyte SSD SATA. And I think I've added an extra S in there. Super solid state disks in a RAID 5. Yeah, all good. Okay, so really, we've got that DevOps jump host. We've got the VBR server. We've got this. We're going to now move this VM1 server in here as well. So for observability, we have this already today. We don't have that 5-node Talus cluster, so I'll touch on that later on as well. But ideally, I want some way of being able to provision those VMs and then add them into my Omni dashboard so that I can then create a cluster from those. I think what I'm trying to say here, and I might say this later on, is about how do we send that to the cloud? So from a VBR point of view, you want to have a copy, potentially you want to have a copy of your backups as close to your production environment as possible, and then you might send that off into cloud for 7+ days. Obviously we're in a lab. I'm not really that bothered about any of this. There is nothing that stops my house working if I don't have it. It's a playground. It's a playground for learning. I've seen a lot of my friends in the community talking about HomeLabs again recently, which is spurring me on to get hands-on and learn. And I would say this is 100% the best way to get hands-on and learn is by creating something. And you don't need to go full hog into 1070-60s. You can do this with an old laptop. You just don't have the same like performance and compute power, if you will. So yeah, another goal is to create another 5-node K3S cluster, probably leveraging Rancher to manage that. Equally, we do a lot with Red Hat OpenShift. So again, wanting to find a way of how do we quickly provision these nodes, these virtual machines, to act as those areas. What else am I going to add? I believe we're now just going to mention around the Raspberry Pi. So let's bring... Oh, so the other idea was we could leverage the Hyper-V or the Proxmox to present... We could create a true NAS box, basically. I also, in the vSphere environment, I have a 3-node MongoDB replica set, and that's because of some of the native capabilities that we have within Veeam. I will obviously indeed like have them running in that cluster as well, in the Kubernetes cluster, as well as Kubevirt. One of the big goals of doing bare metal is the fact that I wanted to do some nested virtualization in there as well, and we see a lot around Kubevirt and being an alternative hypervisor to vSphere and others, and a progression on that front. So making sure that I have hands-on with the native open source project. I mean, most of ours is coming through OpenShift virtualization and SUSE Harvester. But ultimately, if you understand Kubevirt, you're going to understand what those guys are doing, or those are doing on that front. So yeah, we're going to have MongoDB replica set. We're going to have some Postgres. Postgres actually holds some of the little applications that I've built and some data around that. So we're protecting that using that Veeam server. I can't remember what I'm doing here, but maybe get the nodes. Yeah, so when you go to Omni, you're using OIDC to connect to that. I don't know if I bring that into the fold, but basically so there's your 5 nodes that are in that green box to the left. They're all running Rook-Ceph. They're what the difference here though is that I'm running ArgoCD on top of this. So the CNI is installed. I think I dropped that down now so to make it easier to distinguish. but ArgoCD is deploying Rook-Ceph as well. So everything that at the moment, I mean, I don't have MongoDB, I don't have Kubevirt, I don't have. You can see what I have running in that cluster, but I do have ArgoCD and I do have Rook-Ceph, and the goal there is obviously to run everything through Argo as much as we possibly can. That will be the source of truth, or at least it will connect to the source of truth, either from a Helm chart repository or from a Git repository perspective. So we have a lot of goals around other applications that we'll have running there. So just, I guess, wrapping up on a few things here is that we can bring in ArgoCD as a bit of a layer underneath Omni, or to the side of that. We'll move Cilium down. Cilium is acting as our CNI. We'll also deploy Kubevirt via ArgoCD. Cilium was deployed via the Cilium CLI. And I'll tidy this does get tidied up later on. And then the final part of the physical hardware is this Raspberry Pi that is a Pi 4B with 4 gig of RAM. It's massively memory constrained, even with such a small requirement operating system such as Talus. It's still not ideal. So yeah, this is a Raspberry Pi. We're using that inside of Omni, and we've actually deployed a single node cluster. So this is a worker and the control plane, and we've got a couple of applications running on that, but it's not running ideal. So as soon as I can get hold of a beefier Pi 5, then that will be in there as part of that story. Okay, so what else? What else am I missing here? Like, I know I've been rambling on, and all we've done is look at Excalidraw, which, by the way, is an amazing tool for jotting down documentation, documenting your whatever. Like, in terms of, this could be useful for documenting HomeLab, but equally it could be really useful for documenting really anything. I think just before we wrap up, I think it's important, like, so ArgoCD, GitOps, CD, or continuous delivery, continuous deployment, and ideally you want to use that for any Helm chart deployment, any manifest that you might have. I have a K10 app that I'll bring in, which has multiple data services. The nested is still very much part of that Kubevirt journey. Kasten will obviously be deployed within each of those Kubernetes clusters that you see there, and then wrapped around, federated by a multi-cluster dashboard. I don't really know what I'm going to run on the Hyper-V and the Proxmox servers yet. I think there's a web server running on each one. One of the things from a Veeam perspective is portability. I can take a vSphere VM, I can restore that to Hyper-V. I can take a Hyper-V VM, I can restore that to Proxmox. I can take that Proxmox, I can restore that to the cloud, and everything in between and to and from each other. So I think that might be another little bit of content that we bring out if that's useful.